Hello there, I'm Rob Jennings from the Dyscalculia Network. I'd like to welcome you to our third video looking at the key indicators of maths difficulties. Today I'm going to discuss sequencing. Sequencing can be about the very basics of maths, such as counting and place value. It can also be about the order in steps to solve a particular maths problem. Sequencing difficulties affect many aspects of maths learning, such as learning to count, the ability to follow instructions, processing and remembering different counting sequences, such as counting in twos or fives. It could also be about managing the double sequential load when calculating. For example, to work out 4 plus 3, the pupil has difficulty counting and keeping track of how many steps have been counted. In order to count on 3 more, it's necessary to hold in mind the 3 counting steps, while simultaneously sub-vocalizing or counting out loud from 4. I want to look a bit more closely at some difficulties in counting. Counting is the activity that helps pupils to make sense of the spoken number system. Traditionally, it's been assumed that all pupils will become familiar with and will grow to understand the number system through counting. This turns out not necessarily to be the case, as some pupils need to be specifically shown how the base 10 number system is structured. At first, pupils learn to calculate by counting groups of objects, and then develop more sophisticated strategies, starting by learning key facts and then generalizing from these. However, some pupils persist in counting to calculate. The facts never become known automatically, and the very counting becomes a trap. This link between working memory and sequencing difficulties, leading to persistent counting to work out facts, means that little or no progress is made in spite of repeated revision. The causes of problems with counting can be complex, but can be summarized as a young person learns to count as a string of sounds without being aware of the different individual words as separate entities, or has an understanding of what the words actually mean. It could be where pupils with dyslexia or dyspraxia may have memory issues, and counting may place a huge burden on their memory system. Their overall development of counting efficiency may be compromised, and the whole process weakly automized. This may mean they not be able to count up from any given number. Instead, they start from the beginning each time. For example, for a calculation such as 4 plus 3, they may count up in 1, 2, 3, 4, then a brief pause before continuing, 5, 6, 7. Another example is often displayed when you ask a pupil to count in tens up to 100. It's very common to hear the count as 60, 70, 80, 90, 20. As the language is very similar to counting up to 20 in ones. Finally, some of our pupils do not know which number to start from. For example, when asked to count up from 15, they are unsure whether to start the count at 15 or 16. I'd like to finish this overview by discussing counting with fingers, which seems a current hot topic with different views expressed by neuroscientists and educational researchers. Children all over the world learn to count with their fingers, although the way they count often varies, with Europeans normally starting to count from the left hand thumb, whilst in the Middle East they may count from the right hand thumb. Some countries cut out and miss the thumbs out altogether. Using our fingers is a very accessible and multi-sensory way of counting, that can serve as building blocks for later numerical development. The reassurance can also help with any maths anxiety. However, persistent use means that pupils may never become fluent in maths. Indeed, the added cognitive load from inefficient methods of computations, such as finger counting, that arise from a lack of automaticity, often leads to procedural errors and difficulties in learning new procedures and methods. Thank you for watching today.